Hi students, here is the class for you on the topic balancing the chemical equation by using frequency method. In our previous session, same topic balancing the chemical equation, hit and trial method and partial equation method also completed. Now in this session, frequency method, let's discuss. Now students, before going to start the topic, you have to know about what is frequency. In this frequency method, what is meant by frequency means, here you can see number of places of elements appears in the chemical equation. Number of places of elements means, here is the example I am going to write. For suppose KHCO3 plus H2SO4 gives rise to K2SO4 plus CO2 plus H2O. Here is the chemical equation for you, and what is meant by frequency means the number of places of elements. Here are the elements you have to see: potassium and hydrogen, carbon and oxygen, again hydrogen, sulfur and oxygen. Okay, if you take the frequency of potassium, you need to count the places of this potassium. That means in the reactant side and the product side, this potassium is located places. Where it is located, you need to count first of all. Here is the potassium, place 1, and here is 2. Now the frequency F of K is 2. Like that, you need to count the total number of places of these are all elements in this chemical reaction. That is only frequency of the elements. Okay, now let's start about this. Some rules I have given to you. First one, find the frequency of all the atoms. As I told you, frequency of all the elements. First of all, before going to do this, frequency means you have to segregate the elements. What are the elements presented in this specific chemical equation, you need to find out first of all. Okay, for this, element name of the element, and second one is frequency, and third one is order. Order means basing upon its frequency, first of all which element we need to balance. So this is third one, this is second one, this is first one. So name of the element. In this example, here is the example I have written. In this example, here is the first element potassium, and second one is hydrogen, third one is carbon, fourth one is oxygen, then fifth one is sulfur. Okay, these are the elements presented in this chemical equation. Now just I am going to draw some rows here, then only you may not have any confusion. Right, basing upon this chemical equation, you need to count the frequency. Frequency nothing but number of places of elements appears in the chemical equation. Okay, coming to potassium, where it is presented, this is the first place and here is the second place. Now the frequency of potassium is 2. Coming to hydrogen, 1, 2, 3. So frequency of hydrogen is 3. Coming to carbon, 1, 2. So carbon frequency is 2. Coming to oxygen, 1, second place, third, fourth and fifth. So 5 is the frequency of oxygen. Coming to sulfur, 1 and 2. So at second place. So at 2 places only sulfur is presented. Now students, what is meant by order? Let's go for the second rule for this. First rule is completed. Find the frequency of all the elements is completed now. Second rule, start balancing with the element has lowest frequency. So here you can see the lowest frequency 2, and here also 2, here also 2. Potassium, carbon and sulfur. So for suppose if the frequency, number of frequency is same, what we have to do, that also I'll be sharing with you. Let's see rule number 3. If two elements have the same frequency, then the element which is in metallic state would be balanced first. Okay, here you can see carbon and sulfur, these two are the non-metals. So students, here is the potassium is in metallic state, so you need to balance it first. Now we shall go for rule number 4. Both the elements are metallic or non-metallic nature, then balance the elements with highest atomic number first. Okay, let's see now rule number 4, that is now coming to hydrogen. Here you can see potassium is completed, and third one, next carbon and sulfur. In these two, carbon and sulfur, Atomic numbers of carbon and sulfur. Carbon is 6 and sulfur is 16. Okay, now let's see. These two are in non-metallic nature, but you have to take its frequency is same, but you have to take according to this rule number 4. Both the elements are metallic or non-metallic in nature, then balance the elements with highest atomic number first. Now here is the atomic number, highest one is sulfur, so this is second and here is third. Okay, first of all you need to balance the potassium, and second one sulfur, and third one is carbon. And what about fourth one? Here is the frequency 3, so here is 5. Least one is 3, so that the fourth time you can balance this hydrogen, and fifth one is this oxygen. Okay students, now let's go for the balancing the chemical equation by using this frequency method. Here is the example you have. Now let's go for balancing here. So first of all you need to count the frequency and the order. Here is the first one, hydrogen. Here if you see the number of hydrogens only 1, 2, 3. So here if you see here only 2. So what you have to do, this is about hydrogen. Now students, you have to balance it first potassium. So coming to potassium, here is 1 and 2. Now if you place before this compound number 2, now students the equation should be 2 KHCO3 plus H2SO4 gives rise to K2SO4 plus CO2 plus H2O. Now you can see the total number of potassiums here. Here only 2 potassiums and here also 2. Now potassium is balanced. Now coming to second one, sulfur. Sulfur means here you can see only 1 sulfur, here also 1 sulfur. So you can ignore this simply, sulfur is balanced already. Coming to carbon students, here third you have to balance the carbon. Here these two belongs to complete this compound, these two. Now 2 carbons, and here in the product side, here is the reactant side. Reactant side carbon is equal to 2, and in the product side carbon is equal to 1. Now if you place before CO2, this before CO2 if you place 2, now carbon is balanced. Here also 2, carbon is balanced. Now what about the fourth position is hydrogen. Here hydrogen in the reactant side hydrogen is equal to, in the product side hydrogen is equal to. Here you can see 2 plus 2, 4 hydrogens. Here you can see only 2 hydrogens. Now if you place before this H2O 2, then hydrogen is also balanced, it is 4. And what about oxygen students? Here in the reactant side and the product side, what about this oxygen? Let's count it. Here you can see 2 3s 6 plus here already 4. Now total is 10 oxygens. Coming to product side, 4 oxygens plus 2 2s, 4 oxygens plus here 2. This 2 belongs to this complete compound. Okay, now 2. Now the total is 10 oxygens. Now students, equation is balanced. Now what is the final equation? We derived that 2 KHCO3 plus as usual H2SO4 gives rise to K2SO4 plus 2 CO2 plus 2 H2O. Now from this equation we got all the elements numbers according to law of conservation of mass. All the number of atoms in the reactant side and the product side is same. Hence this equation is balanced according to this frequency method. Let's go for next example. Al plus NaOH plus H2O, these three are the reactants. It is LHS left hand side, and NaAlO2 plus hydrogen gas, and these are the products, so P RHS, right? Here is the RHS. Now coming to name of the element, and what about the frequency, and what is the order, correct order of balancing these elements. Let's see now. First of all, you need to count the total number of atoms. Here first aluminium, we can segregate what are the elements presented here. Aluminium, and students, sodium and oxygen, and last one is hydrogen. Okay, and the frequency. Now the frequency means the number of places of elements you need to count. Coming to aluminium, here at how many places where the aluminium is located. Here 1, first place, and here is 2. At 2 places only aluminium is located, so frequency of aluminium is 2. Now what about sodium? Here 1, here 2, so sodium also has the frequency 2. Coming to oxygen, here 1, 2, 3 places. Oxygen is located at 3 places, so frequency of oxygen is 3. Now coming to hydrogen, 1, 2, 3. At 3 places hydrogen is also located. Now students, what is the order? If there is same frequency, then if you get same frequency here, aluminium and sodium also, now you have to consider the atomic numbers of these. Aluminium is 13 and sodium is 11. Now you have to give the first priority to this highest atomic number, so aluminium you have to balance it first. Now second priority should sodium, you should give the second priority to sodium. And what about these oxygen and hydrogen? Means here also same, these are the same frequency. Then students, you can consider the atomic numbers 8 and 1, so this is third time and this is fourth time. You need to balance it. Oxygen third and fourth one is hydrogen. Now for suppose in this equation one elemental representation is located according to rule 5. I didn't discuss with you the rule 5. Here I have written, if any substance is presented in the form of an element in the chemical equation, and also the number of atoms of elements are odd or even, then both sides of the equation difference is 1, then multiply the reactants and products with the number 2, except the elemental substance. Okay, I'll give you an example. Here is the decomposition of lead nitrate. If you see the equation, PbNO3 twice, this is the lead nitrate, and what are the products here? Lead oxide plus NO2 plus O2. Okay, according to rule 5, here is the elemental formation. So present in the, if any substance is present in the form of an element, so this is the element, this is the compound, this is the compound, this is the compound. In the chemical equation also the number of atoms of elements are odd or even, means just this is elemental form. Okay, then you need to count the oxygen numbers here 3 2s 6 oxygens, and here 1 2 3 4 5. So in the reactant side 6 oxygens, in the product side 5 oxygens. So this is even number and this is odd number. Okay, now you have to do subtraction of this. 6 minus 5, that is 1. Now you need to multiply with the number 2. Now simply you can place before these compounds 2 and here also 2. Now you can count these NO2. Here nitrogens are 2 2s 4. If you place here 4, simply accept the elemental substance. So accept this elemental substance, you can ignore this simply. That is about rule number 5. This rule number 5 you can apply in this equation also. In this equation also we have this elemental form of hydrogen. Okay, now let's start the balancing the equation. Now in this equation, in the reactant side, you need to count hydrogen atoms 1 plus 2. So here 1 plus 2, 3 hydrogens. This is about hydrogens. Okay, so 3 is the odd number. And students, coming to the product side, how many hydrogens are there? Here only H2. So only 2 hydrogen atoms, it is even. simply you can subtract 3 minus 2, that is 1. So if you get 1 here, obviously multiply, these are all in the reactant side and the product side, multiply with 2 just by ignoring simply this H2. Now the same equation I'm going to write here, aluminium plus NaOH plus H2O gives rise to NaAlO2 plus H2. This is the chemical equation what we have here. Now if you multiply these reactant side and the product side, just simply you can write here 2 and here also 2, here also 2. Now you can balance all the elements whether they are present, they are same in number or not. For suppose aluminium and sodium, oxygen and hydrogen, this is reactant side, and product side also same, oxygen and hydrogen. RHS, this is only RHS and here LHS. Okay, now let's do it. Aluminium, here 2 aluminium atoms and here also 2 aluminium atoms. For suppose students, if you place any number before the compound, means that number belongs to this entire compound. Okay, you should remember this thing. So aluminium atoms are 2 both sides, reactant side and the product side. So aluminium is balanced. Now coming to sodium, here 2 sodium atoms and here also 2 sodium atoms, 2 and 2. And oxygen, here 2 oxygens plus here also 2 oxygens, so 4 oxygen atoms, and here you need to count 2 twos, here also 2 is located, so 2 into 2, 4 oxygen atoms. Coming to hydrogen, students, all the atoms are balanced now up to now. So hydrogen, what about hydrogen? Let's see now. 2 hydrogen atoms here plus here you can see 2 twos, 4 hydrogen atoms. So total 6 hydrogens are presented in the reactant side, nothing but LHS. So coming to product side, here only 2 hydrogens located. So students, if you place before this H2 3 H2, now only it will become into 6. Now total equation is balanced by using this frequency method. Okay students, right, let's go for the third example now. I hope you understand this example. I shall start with the next one. With this example, I have drawn the tabular form also, name of the element, frequency and order. Here is the example. Let's see, KMnO4 plus KOH gives rise to K2MnO4 plus O2 plus H2O. This equation you need to balance now according to frequency method. You need to find out the name of the element first of all. Here potassium and manganese and oxygen and hydrogen. Okay, these are the elements. Coming to frequency, students, number of places of elements you need to count at where the elements are presented. Let's see, here is the potassium 1 and 2, 3. At 3 places potassium is located, so frequency of potassium is 3. Coming to manganese, here 1 and 2 at 2 places only. And oxygen 1, 2, 3, 4, 5. At 5 places oxygen is located, so the frequency of oxygen is 5. Coming to hydrogen, here 1 only, 2. So what is meant by an order? What is the order now? Let's see. So you have to give least priority. For suppose if you have the same frequency, if this is manganese, this is hydrogen. So students, here you need to give first priority to this manganese. Why? Because it is in metallic nature. Okay, now this is the second one and third, and last priority goes to oxygen. Okay, now here O2 is there, so metallic, this is in elementary form. So according to rule 5, what we have here, O2, presence of O2, then you have to do the difference in between the reactant side and product side, but here there is no presence of oxygen here. Let's see how we can balance this equation. First of all, in this skeleton equation only, how many potassium atoms are presented and how many manganese, how many oxygen, how many hydrogens you need to count. Coming to reactant side, only potassium is 1, 2. 2 potassiums are there, here also 2. Now potassium is balanced in the skeleton equation only. Now coming to manganese, here 1 manganese, here also 1 manganese, so manganese also balanced. Now coming to oxygen, here 4 oxygens plus 1, 5 oxygens. Then here 4 plus 2, 6 plus 1, so 7 oxygens. So you need to balance it now. Now the same equation I am going to write here. KMnO4 plus KOH gives rise to K2MnO4 plus O2 plus H2O. You need to balance first of all that oxygen. So if you place in front of the compound KMnO4 4, now same, here also 4, here also 4, except this elemental form of oxygen. Now you need to count how many potassiums, how many manganese, how many oxygens, how many hydrogens. Here also same, O and H. Coming to potassiums, 4 plus 4. In the reactant side, 8 potassiums are located. Coming to in the product side, 4 2s are 8. So 8 potassium is balanced now. Coming to manganese, students, here manganese, this 4 belongs to this entire compound, okay. So manganese also 4 here, and in the product side manganese also 4. Now manganese is balanced. Now oxygens, here 4 4, 16 plus 4, so 20 oxygens came in the reactant side. And what about the product side? Here 4 4, 16 plus 2 plus 1, 18 plus 1, 19 only came in that in the product side. Now students, if you add 2 here before the compound H2O, if you place 2, now here 16 plus 2 plus here 16 plus 2 plus this 2 belongs to this entire compound, okay. Now 2, now the number is 20. So oxygen also balanced here. And what about hydrogen? You need to count here 4 hydrogens, okay, 4 you can write down. And what about here in the reactant side, 4 completed, in the product side 2 2s 4. Now hydrogen is 4, hence this is balanced. Okay students, I hope you understand. This is about balancing the chemical equation by using frequency method. These are the examples we have discussed in this session, how to balance the chemical equation by using this frequency method. And what is meant by frequency also I have told to you. Number of places of elements appears in the chemical equation, entire chemical equation, the number of places you need to count. Here is the example. By using this example also I have explained to you everything, students. So these are the rules for finding the balancing the chemical equation, the finding the frequency also. These are the rules, you have to note it down, okay. These are the 5 rules, and 5th rule is very special one. No need of confusion in this, okay. No need of confusion, okay. Just I have written the example also here with the help of lead nitrate, right. And what is your opinion? And if you have any doubt also, you can convey in the comment section. Please subscribe to this channel if you understand this class. Okay students, have a nice day. Thanks for watching.